Hello everyone, so we're going to cover real quick how to find the minor losses for the Hello everyone, so we're going to calculate real quick how to find the minor losses for the water circuit lab. So the minor losses, we have different fittings. We have the elbows, the T-couples, the bulbs, and the expansion and the contraction. And you can see we have this formula that comes from the lab, which is the minor loss formula, which is the same one as the major loss, just uses the equivalent length, a little different term, and it's also shown here in this form with a K. So this K is nothing but just a substitution of the F and the L and D, L over D terms, but both of them are pretty much the same formula, used just for different fittings. So the first formula, the first part of the formula, using the equivalent length, you're gonna use it for the elbows, the T-couples, and the valves, and you'll find it using table 8.4. For the second part of the question, the one with the K, you're gonna use that one for the expansion and the contraction using figure 8.15. And both of them are given on Blackboard and they're really easy to follow. So for the equivalent length for the elbow, T-couples, and valves, you go to table 8.4, and here it gives you some values to substitute for this term. So you can see we have different types of valves, gate, glove, angle valve, and everything. And the one we're using in the lab is the bulb valve. And so you can see it has a equivalent length of 3. So you're simply going to substitute that 3 over here for this term. So it will be the friction factor times 3 times the velocity squared over 2, and so on and so on. So you're going to do the same thing for the elbows, which is using the 90-degree elbow, standard elbow, which in this case is 30, and your standard T-couples, you can use the flow to run 20. And so you can see it's really simple, just plug and chug. Now for the expansion and contraction, you're using the formula that has the K on it. So we're gonna go to figure 8.15, and it looks something like this. So this is figure 8.15. You see you have on the left side you have the contraction loss coefficient, or Kc, and on the right side you have the expansion loss coefficient, or Ke. And on the x-axis you have the area ratio. So the ratio between the biggest area divided by the ratio between the biggest area and the smaller area of the pipe. So depending on from what side you're coming from, the contraction or the expansion, both of these bigger sides are pretty much the same, which is has a diameter about 2 inches, and this small section has a diameter of 1 inch, which is the regular pipe that we're flowing through. So you need to find first the area ratio for contraction or expansion. So let's try first one just doing the contraction in this case. So area 2, which is the small one, divided by the area 1, which is the biggest one. Since you can do area over area, diameter is the same. Either way, the pi and all those things are gonna get canceled. So it will give us an area ratio of about 0.5. So we go here then to the x-axis. So we start here 0.5. You can see we have two lines, one pointing to the left, one pointing to the right. We're gonna use the one pointing to the left because that is for the contraction. If we were to use the one for the expansion, we'll do it to the right. So we're using this first line, and right where it is right here, we go to the left, and we find our K value will be of 0.2. So then our Kc is 0.2, and let's just do the Ke real quick. So the Ke in this case, we're doing again is the ratio between area 1 to area 2, and after doing this, we're gonna get also a value of 0.5. So over here the same. Now we use the other line, and we move to the right, which is about close to 0.3. So we can say that maybe Ke is about 0.25 or 0.3. You decide whatever you think is better. You can just do this on your own. You can print the paper, or you can do it on your computer. This is just an example that I'm doing real quick. You can probably do this much more accurate. But now you have your K values, you can just go back to the formula over here, the K formula, plug it in, and find the minor losses for the fittings. I hope that helps you guys. If you have any questions, just let me know, and keep on doing a good work.